Okay, we are on to our next section here in Earth Science, and it's the air masses section. Pretty quick section, shouldn't take us very long. Pretty simple stuff here, probably some of the easier stuff we've done in all the classes so far this year, but air masses. So what are they? Well, air masses, first of all, are the main reason for weather. Without air masses, we could not have weather here on Earth. And as you can see, basically it's from a satellite view of air masses. Different air masses are different colors, as you may or may not know. The warmer the air mass is, the more red or orange it is, and the colder it is, it's more gray or more white. But these differences in temperature are the main reason we have weather. Whenever these two, maybe a hot air and a cold air collide, you have weather. Or sometimes it deals with the moisture in the air mass, whether it be a lot of moisture or not much at all. But these are the main reason for weather. And basically all these are large movements of air, really large movements of air. I know this animation is hard to see here, this weather map, but below that you can see the outline of the states, basically the entire country of the United States. You can see that these air masses are really, really, really large. Sometimes they take up big chunks of the entire country. So large bodies of air masses, and they are responsible for the weather here, not only in the United States, but worldwide. So the air in an air mass, now this is going to sound really weird, but the air in an air mass is always similar to the air mass itself, meaning this: if an air mass goes into an area and it's warm and wet, meaning it's got a hot temperature, but it's also got some moisture or precipitation in it, then the air inside of it is also warm and wet. Now that sounds weird, but basically air masses go into an area and they sit over the top of an area. And whatever area they go into, and when they sit in that area, the area below it is going to be the exact same. So in other words, the air is always similar to the air mass itself. So the air below it is always similar. So once again, if it's cold and dry, meaning maybe it came from the North Pole or the South Pole and doesn't have much moisture, then the air inside of it and below the air mass is also going to be cold and dry. So the air in the air mass is always similar to the air mass itself. So that's why air masses are so important with weather, because when they go into an area, the air below the air mass, the large air mass, the clouds basically, is always the same as the air mass itself. So they're exactly the same. Air masses are really, really, really big. They're huge. Sometimes when an air mass moves into an area, it may take days and even weeks to move through an area. Again, if you look at the animation below, that's the satellite imagery. Basically, a satellite above the Earth is tracking all the different air masses worldwide. And what you'll see is these are really big. Like, these take up large areas of the Earth. And these what's called air mass weather. Basically, air mass weather is when a air mass moves into an area and it doesn't move. So therefore it causes the weather to stay the same every day because it just won't move in that area. Sometimes this happens here in Kansas City in the winter. A cold air mass can move over the top of us, and that's why we can have some of these long weeks or maybe 10 days where it's really, really cold for a long period of time. That's air mass weather. Same thing happens in the summer. Summertime, a really hot air mass moves into the Kansas City area, and maybe it'll stay for a week, maybe sometimes 2 weeks. The weather in that area will also be very hot because the air mass doesn't move, and that's called air mass weather. So air masses are really big. They cause what is called air mass weather, basically when the weather in an area does not change for an extended period of time. So there are 4 major types of air masses, and they depend on where they start or where they begin. First one is a continental air mass. Just like a continent is land, a continental air mass starts over land. So it doesn't start over the ocean or maybe a large river or a lake. It actually starts over land. That's why it's called continental air mass. An easy way to remember that is continents are land, just like North America here in the animation below is a big chunk of land. Those air masses start over land. That's why they're called continental air masses. They start over land. Next one is a maritime air mass, and those are the ones that start over water. Most of the time these start in oceans. However, big lakes and even in some situations a river might cause a air mass to be a specific way. And if it starts over water, it's called a maritime air mass. So an easy way to remember that, if you've ever been to a marina, the word is basically the same. Maritime means water-based or ocean-based, so a maritime air mass means starts over water. Continental starts over land, maritime starts over water. From then you break it down even further, and that the next step is, where did they come from in terms of area on the Earth? The first place they come from is the poles, north of the South Pole. Here in the United States, we get most of our air masses from the North Pole because we're just closer to the North Pole. Those are called polar air masses because they start at the Earth's poles. That one's pretty easy to remember. Polar sounds like sounds like pole, so therefore polar air masses start. Most of the time here in the United States, we get ours from the North Pole. The final type of air mass is a tropical air mass, and this is an air mass that starts in the tropics. In other words, down by the equator or close to the equator, the warm parts of the Earth. Most of the time a tropical air mass is going to be warm, whereas a polar air mass would be cold because it's coming from the north of the South Pole. A tropical air mass starts in the tropics or the warmest parts of the Earth. So the four types of air masses: continental air mass starts over land, maritime air mass starts over water, polar air mass starts over the Earth's poles, tropical air mass starts over the tropics or the warm parts of the Earth. So further to break these down, what we do is we mix them. Excuse me. Air masses are abbreviated by how they mix. So they're abbreviated by their first letter, the first letter of the air mass, for example, C for continental or P for polar. And they're also abbreviated by the second letter as well. So what you do is you combine the letters. So for example, CT would stand for continental tropical. MP would stand for maritime polar. MT would stand for maritime tropical. So basically it's pretty easy to remember, just like the initials in your name or my name. If you abbreviate an air mass, you're simply taking the first letter of the two air masses from which the two air masses that combine to create the larger air mass. You simply abbreviate it. So once again, when you mix the air masses, they come together and they mix, you simply abbreviate by the first letter. For example, again, CT would be continental tropical, CP would be continental polar. Most weather in the United States is caused by continental polar and maritime tropical air masses. Whenever we have large storms here in the Kansas City area, most of the time that's because we have a continental polar, a dry, kind of cooler air mass that comes from the north, usually the North Pole, and it collides with the maritime tropical air mass, which is warmer and has moisture. And whenever you have kind of two opposite types of air masses, when those two combine, you're going to have storms in those areas. So we get most of our weather here in the United States from when continental polar, so those air masses that are dry and come from mainly the North Pole, and a maritime tropical, which is an air mass that is wet and comes from the warm part of the Earth, when those collide. So continental polar, abbreviated very easily, CP. Well, what is it? Well, first of all, it comes from the north. That's why it's called polar, but it's very cool. But it's also very dry. Continental polar, because they don't really have a water source over the top, they come down from the North Pole and they're pretty dry and cold. So if you've ever had a winter day that's really, really cold and you kind of have itchy skin, that's caused by a continental polar air mass, because those air masses are cold and they're dry. So they produce days in the summer where it's in the winter when it's kind of weird because you go outside and the sun's out, but it's really, really cold. Those days are continental polar air mass days because you have the very dry air, so that leads to clear skies, but you also have a polar-based air mass, so therefore it's cold as well. So you have cold, dry weather that produces very clear skies, and also the colder, extended cold periods during the winter. Continental polar. Next, maritime tropical. Just like it says, maritime coming from the ocean. So these, as you can see from the arrows below, they start over the ocean or maybe sometimes a larger lake, but they're warm and they're loaded with moisture. They're warm because of where they come from or where they start, and that's the tropical regions of the Earth. So usually down by the equator. And they're loaded with moisture because they start over the oceans. And what happens whenever a maritime tropical or MT air mass comes into an area, you have very hot temperatures and you're going to have a lot of precipitation. Once again, when a maritime tropical air mass collides with a cooler air mass, you're going to have storms. So since the maritime tropical has so much water in its air mass, it will automatically lead to precipitation. We are getting ready to get very close to a time of the year in which it's going to heat up, and you will notice that there's going to be a lot more storms. And most of the time that's because maritime tropical air masses are moving into the area. Maritime tropical or MT, they're hot and they are full of precipitation or moisture. Next one is a maritime polar air mass. They come to the United States from the north, like I mentioned before, the North Pole, with these air masses. And it usually starts as a very cold, dry air mass over the North Pole, but as it moves more south, as it goes across the United States, usually it's going to pick up more moisture. But it is maritime polar by the time it gets us, because it kind of goes over the ocean and picks up more moisture, and it's already cold, so therefore it kind of will warm up over time, and that's why it changes kind of to a medium temperature. But a maritime polar air mass, if you break it down, maritime is water, and then polar is from the pole, so it's going to be a very cold water-based air mass, usually from the North Pole. So maritime polar, or MP. And these cause very heavy precipitation. So anytime in the winter when we have a very large storm, we have a lot of snow. We didn't have much. We haven't had much over the last few years, but this can produce heavy precipitation because it has so much moisture in it, because it does start over the ocean and it is cold, leading to snow. Continental tropical is our last one here. Continental, tropical, if you break it down into two words, continental meaning land-based and tropical meaning from the warm parts of the earth, abbreviated very easily as CT. Very hot and dry, because it's hot because of where it comes from, the tropical regions of the earth, but very dry because it starts over land. The unfortunate thing with a continental tropical air mass is it can cause what's called a drought in an area for a long time. Some of you may have heard recently California has been going through a big drought. One of the reasons is they have a continental tropical air mass that's kind of just been sitting over at California for a long time. And since it doesn't have much moisture because it started over land and it's very hot, you're not going to have a lot of rain. So what happens is something called a drought happens, in which it doesn't rain much, so the water in the area kind of starts to go away. And that's what's happening not only in California, but a lot of different areas of the world right now, because we have continental tropical air masses that are extremely dry, but also extremely hot. So that's it for the notes for air masses. Like I had mentioned, very simple set of notes. Show me these notes so you can get your points. Good luck.